Hi everyone, in this video we'll go through few 5 marker problems from compound angles, multiple angles, submultiple angles chapter which is related to trigonometry. In these 5 marker problems, we have to prove trigonometric expressions. In this example, we have to prove that this particular statement cos A plus B into cos A minus B is equal to this particular statement, and also this is equal to this statement. So basically there are two trigonometric expressions here. These, so you'll have to prove that this expression is equal to this and this. So separately we'll have to prove both of them. So let's take this LHS first. Let's consider this portion as LHS. This is RHS 1, RHS 2. Basically two equations, one RHS 1, the other one is RHS 2, just for identification, right? So now we'll start with LHS. LHS is cos A plus B into cos A minus B. Now we have cos A plus B here. What is the formula for cos A plus B? It is cos A cos B minus sin A sin B. So cos formulas are easy, right? You have to put cos on one side and sin on the other side, right? Similarly, we'll expand cos A minus B. So cos A minus B is cos A cos B plus sin A sin B. Notice the signs here. For cos A minus B, the sign is plus. For cos A plus B, sign is minus. So it is just the reverse. Now you multiply both of these. When you multiply, you will see that some terms will get cancelled, right? All these terms are cancelled. Now you're left with cos square A into cos square B minus sin square A into sin square B. Now, using this expression, we'll have to derive this equation and this equation. We'll have to derive this. So what we can do is, so since there is square here, see, you notice here there is cos square and sin square. So immediately this should strike to you that we'll have to use this particular formula. Sin square A plus cos square A is equal to 1. Right? Now, this can be written in two forms, right? Sin square A plus cos square A is equal to 1 means cos square A is equal to 1 minus sin square A. You can take this to the other side. You will get cos square A is 1 minus sin square A. Also, you can write it as sin square A is equal to 1 minus cos square A, right? You can take cos square A to the other side. So it will become 1 minus cos square A, and that is equal to sin square A, right? So now we'll use both of these substitutions. First we will substitute cos values. Then second time we will substitute sin values. Once when you substitute cos values, you will get this. And second time when you substitute sin values, you will get this expression. So let's check that out. So for this expression, what is it you have to substitute, right? So we need cos square A and sin square B. We don't need cos square B. Here we have cos square B. We don't need this, right? So we'll have to eliminate this, right? We also don't need sin square A. We don't need these two expressions, but we need cos square A and sin square B. Now what we will do, we will substitute cos square B. What is cos square B? It will be 1 minus sin square B. So we'll substitute here. Cos square B is 1 minus sin square B, right? We will not substitute sin square A. We'll just leave it, right? Because there's a possibility that this might get cancelled. So just leave it, right? So now, when you expand, you'll get this kind of an expression. Now you can take common factor. So notice, sin square B is common here, sin square B is common here. So you can take sin square B as common factor, put minus sign outside. So you will get cos square A plus sin square A. Now this is nothing but equal to 1, correct? This is equal to 1. So when you substitute, you'll get cos square A minus sin square B, which is what we wanted, right? This is the first expression. So we have proved this. This is RHS 1, we have proved. Now we need to prove this second statement. We need to get the second statement. Now let's observe the equation. This is the equation, right? Let's go back to this equation, equation 1. What is that we don't need? We have cos square A. We don't need this. We don't need cos square A, right? And we also don't need sin square B. We don't need both of these. We need cos square B and sin square A. So what we will do, we'll substitute sin square B. We'll substitute sin square B with this particular formula, 1 minus cos square A. So when you substitute sin square A as 1 minus cos square A, here we are substituting, right? This was originally sin square B. Now we substituted this with 1 minus cos square B. Now you expand. Now you will see that there is a common factor between this one and this one, right? What is the common factor? Cos square B. So you take cos square B outside, and then you'll get cos square A plus sin square A. This will become 1. So 1 into cos square B minus sin square A. So we have got the expression. We've got RHS 2. This is RHS 2. Cos square B minus sin square A. Cos square B minus sin square A. Hence we have proved both the statements, right? RHS 1 and RHS 2. So just to reiterate, first expand this trigonometric expressions cos A plus B, cos A minus B. You'll get one equation. Now use this sin square A plus cos square A formula First time you substitute cos square A, you will get this RHS. Then second time you substitute sin square A and you'll get this particular expression. And if you don't know what you have to substitute, look at the expression, right? If there is, just look at the expression, whether it has cos square A, whether it has sin square B, just look at it, and whatever is not there in this particular expression, try to substitute that, right? For example, in this expression there is cos square B, here there is no cos square B, so try to substitute for cos square B. So this is one clue. Let's go to 20th sum. Here you'll have to prove that sin A plus B into sin A minus B is cos square B minus cos square A. Again, use the sin A plus B formula, which is sin A cos B plus sin B cos A, and sin A minus B formula, which is sin A cos B minus sin B cos A, right? Basically, the signs will vary, right? Here the signs will vary. Now, when you multiply, two terms will get cancelled, right? And you'll be getting sin square A into cos square B minus sin square B into cos square A. So we need this particular expression only in terms of cos, right? We need to only have cos, not sin. That means we'll have to eliminate sin. We'll have to somehow eliminate sin. How we can eliminate sin? Using this formula. Sin square A plus cos square A is 1. Therefore, sin square A is 1 minus cos square A. Now substitute 1 minus cos square A here instead of sin. So you'll substitute. Here also you'll substitute. Here also you'll substitute. Right? Here you're substituting and here you're substituting. Then you expand. Terms will get cancelled. Then you'll be left with cos square B minus cos square A, which is nothing but RHS. We have proven. So let's go to 22nd sum, where we have to prove sin cos. We'll have to prove this entire expression is equal to 1. So this is very, very simple. Just look at the statement once, right? If you look at it, you have pi by 3 minus a here. You have pi by 3 minus a here. Pi by 3 minus a here. Then you have pi by 6 plus a. Pi by 6 plus a. So basically, this is like sin A cos B and cos A sin B. It's of this particular form, right? You have sin cos, cos sin. So this will be sin formula. This will be sin formula. Sin A plus B formula. Plus because there is plus here. There is plus here, so you'll have plus here. This is sin A plus B formula. Now what is A here? This will become A. Pi by 3 minus A is A. Pi by 6 plus A is B. So instead of A, we have pi by 3 minus A. Instead of B, we have pi by 6 plus A. Now you substitute both. A and A will get cancelled. You'll have pi by 3 plus pi by 6. What is pi by 3? Pi is 180 degree, right? Pi is 180 degree, right? So 180 by 3 and 180 by 6, you'll get sin 60 plus 30, which is sin 90. And sin 90 is 1, right? You have to remember this. Sin 90 is 1, which is equal to RHS. So hence we have proved this particular expression. Now let's go to the 24th sum. Here you'll have to prove that sin 105 plus cos 105 is cos 45. Here what we'll have to do is, we'll have to split 105 as 60 plus 45, right? 60 plus 45. Then use sin A plus B formula. Sin A cos B sin A. That formula we'll have to use. Here it is cos A plus B formula, right? Here it is cos A plus B, which is cos A cos B sin A sin B with minus sign. Because it's plus over here, you'll have minus as per cos A plus B formula. Now you have to substitute the values. Sin 60 is root 3 by 2. Cos 45 is 1 by root 2. So substitute all the values, right? And on simplifying all of this, you'll get 1 by root 2. Now what is 1 by root 2 in that trigonometric chart? 1 by root 2 is nothing but cos 45. Even sin 45 is 1 by root 2. Sin 45 is equal to cos 45 is equal to 1 by root 2. Right? Since we want the RHS, we want cos 45, we will put cos 45 here. Hence, we have proven this particular expression. Now, let's go to 25th sum. Cot 2a plus tan a is equal to cosec 2a. Now, we have to express this in terms of cosec. What is cosec? Cosec is 1 by sine, right? This is cosec, which means we can't have tan and cot here. We have to represent tan and cot using sine, right? Because ultimately we need to prove this in terms of sine only, right? So, we'll say cot 2a is, what is cot? Cot is cos by sine. Cot is cos by sine. So, we'll substitute cos 2a by sin 2a, and tan is sine by cos, right? Sine by cos. Now, we'll substitute. We'll take the LCM. LCM is sin 2a and cos a. So, to get this particular denominator, here you already have sin 2a. You have to multiply this with cos a. Only then you will get this particular denominator. So, you have cos 2a into cos a here. Now, what should you multiply sin a with? Here you have already cos a in the denominator. you should get sine 2a into cos a. So you should multiply with sine 2a. You should multiply this with sine 2a. Only then you'll get this particular denominator. Because there is already cos a here, you multiply with sine 2a, you'll get this denominator. Now on multiplying, you'll get this term. Now you notice this again. Here all cos values are one side, sine values are one side. This is of the form cos a minus b, cos a minus b. Cos a minus b is cos a cos b plus sin a sin b. So this is cos a minus b. So instead of a you have 2a, instead of a you have 2a, and instead of b you have a. So 2a minus a. 2a minus a is a, cos a, and this denominator, right? Cos a and cos a will get cancelled. You are left with 1 by sin 2a. What is 1 by sin? Cosec, right? Cosec 2a. So we have proved. With this, we have come to the end of this particular topic. We will go through some more 5 marker problems in the next video. Thanks for watching. Hope this video was useful.